called covalent bonding. So we can use two terms here. We can say that this is molecular bonding or covalent bonding. So molecular or covalent. And the difference here is that the atoms that come together are not going to transfer electrons, but they're going to share electrons. Now this makes things a lot more complicated because of the fact that there's no ions that are formed, there's no attraction between the particles, other than the fact that they're attracted by creating that shared electrons. This is always going to be between two nonmetals, and it's going to form molecules. No ions are formed here. Okay, so we form molecules. All right, so when we have something like water come together to form, the hydrogen has an electron. Well, oxygen has an empty space for its electrons. We'll talk more about this when we get to Lewis structures. And we have hydrogen here. What's going to happen is they're going to share these electrons. These are going to create what's called a bond. And we get a water bond to form between these two. And this is what we would call the water molecule. Now there's no charge that's holding them together. It's the fact that when we look at that hydrogen, it has a 1s orbital. Oxygen has the 1s, 2s2, 2p4. Well, if we look at that 4, that 2p4, if I draw that over here, that 2p4 orbital has those two empty spots in it. So you get 1, 2, 3, 4. There's two empty spots for the hydrogens to bond into, and they share and overlap in this region and in this region. That's why we get two bonds, and then the 1s from the hydrogen fits into those locations, and you get this shape to your molecule. You get a hydrogen, water molecule to form based on the sharing of electrons, not forming ions. So what you end up with, and here's the big difference, is you get this little glob or group of molecules that act independently of each other. Okay, there's two different kinds of forces going on in our water molecules, or in our sample of water. You have the force inside the molecule that's holding the atoms together. Let's do a different color there. Let's go ahead and do green. So there's a force holding the hydrogens and the oxygens together. Right? There's a bond here which we call the covalent bond that keeps the molecule together. Then there's another force we're going to talk about in a later chapter that keeps the two water molecules together, that bonds all of these together. So there's different kinds of forces that are happening inside the water than we have happening inside the ionic compounds. And the same thing goes on with something like this. If we have oxygen, so this is O2, they bond together to make oxygen molecules that are going to stay together as individual little units or groups. Same thing with carbon dioxide. We're going to talk about why water has this shape and carbon dioxide has this shape in the next few lessons. All right, so that's pretty much the review of covalent and ionic bonding, and we're going to try to explain covalent bonding in a lot of detail. We'll talk more about this fact that there's two types of covalent bonds that's going to come up in a later lesson. The fact that some of these bonds can be polar and nonpolar.